Hi everyone, my name is Daniel. Today I'm gonna show you how to build an elevator model using MATLAB Simulink interfacing with the LEGO Mindstorms NXT. Let me show you the elevator model I built here. A DC motor is fixed on the top of the elevator frame. The DC motor is dedicated to pull the elevator car up, acting as a pulley with the spool and thread. The motor encoder is connected to port A on the NXT brake. The two touch sensors on the side of the elevator frame are used to control the elevator car movement. If you push the up touch sensor, which is connected to port 1 of the NXT brake, the elevator car will move up one floor. If you push the down touch sensor, which is connected to port 2 of the NXT brake, the elevator car will move down one floor. There are 7 floors in the elevator model, which is from 0 to 6. The height difference between each floor is 5 centimeters. The elevator car should stop when the yellow measuring pole reaches the yellow labels. I also have an USB connection that connects the NXT brake to my laptop with MATLAB Simulink installed. This is the closed-loop position control model for one step. I set the step up time to 2, the final value to 5. Set the step down time to 4, the final value to -5. For the PID controller, I set the proportional gain to 5, other gains to 0. I set the power saturation to -40 to 40%. To run the control model, click Tool, Run Target Hardware, click Run. After run the control model, go to MATLAB command window, plot the output data, set X label to time, Y label to height. Then we can see the figure. Using cursor, the height is 0 until 2 seconds. At 2.8 seconds, the elevator car reached the top. Then it stays steady at 5.013 cm until 4 seconds. The elevator car reached the lowest point at 4.72 seconds. Then it will stay steady at -0.07 cm. The steady state error is caused by the backlash of the NXT motor and the weight of the elevator car. Then let's consider the simulation model. I set the step up time to 0, the final value to 5. Set the step down time to 3, final value to -5. For the PID controller, I set the proportional gain to 5, others to 0. I set the input voltage saturation to 40% of maximum and minimum. And I calculate the gravity torque disturbance using mass multiply the radius of the spool. Then run the simulation. Go to MATLAB command window, plot the output, set X label to time, Y label to height. Using cursor, we can tell the peak value is 5.16 centimeter at 0.76 seconds. The steady state value is 4.96 until 3 seconds. The lowest point at 3.6 seconds. The final value is negative 0.03 centimeter. The simulation result is very close to the control model result. Now, let's consider the real-time control model. The up touch sensor is connected to port 1. The down touch sensor is connected to port 2. For the height saturation, I set the upper limit to 30, the lower limit to 0. For the PID controller, I set the proportional gain to 5, others to 0. For the power saturation, I set the upper limit to 40, the lower limit to negative 40. To run the control model, click Tool, Run on target hardware, Run. Wait until the NXT brake is running and make sure the elevator car is in 0 position. If you push the upper touch sensor, the elevator car will move up 1 floor until it reaches the top floor. If you push the lower touch sensor, the elevator car will move down 1 floor until it reaches the bottom floor. Push the touch sensor longer than half second, the elevator car will move 2 floors at one time. If you want to stop the control model, click Stop Real-Time Code. Then go to MATLAB command window, plot the output data, set X label to time, Y label to height. Then we can see the figure. Using the cursor, we can tell the height is 4.898 centimeter at the first floor. From the 5 centimeter grid line, we can see the steady state error and the overshoot is very small. Thanks for watching. Hope you learned something.